Okay, section 2.2, more on functions and their graphs. For those of you that are business majors and have to take survey of calculus, or those of you that are science or math majors and have to take regular calculus, you will study where functions are increasing, decreasing, and constant. Now, there are official mathematical definitions of those concepts. That's beyond what we need. We'll just go with what I like to call visual definitions. A function is increasing on an interval if its graph rises on that interval from left to right. A function is decreasing on an interval if its graph falls on the interval from left to right. So, shown below is a function, the graph shown below is increasing on the interval negative infinity to 0. So it's increasing right here. Increasing. Because as I go from left to right, it's falling. And it's decreasing over there. So decreasing on 0 to infinity, increasing on negative infinity to 0. Notice that y-coordinate 4 has nothing to do with the answer. It's the intervals of the x-axis over which or under which the graph is rising or falling as you go from left to right. And then a function is constant on an interval if its graph is horizontal on that interval. So increasing, rising, decreasing, falling, constant, horizontal as we go from left to right. Okay, example 1. Use the graph to determine where it's increasing, decreasing, constant. So let's do increasing first. We'll do increasing in blue. There. And there. So increasing in blue. So on the left forever, to x equal negative 3, or we would write that as negative 3, or negative infinity to 3 with parentheses. And then x equals 0 to x equal 3, x coordinates. And so that would be 0 to 3. And then you're going to have to read what they want for the answer. Perfect would be this, negative infinity, negative 3, union 0 to 3. But you'll have to read what the computer wants. Sometimes they'll put a union symbol between things. Sometimes they'll say separate by a comma. Just read to see what they want. Now, on a test for me, I don't care. Just give me the intervals. So in blue, that's where we were increasing. Decreasing. In red. So we're decreasing just right in there. And that'd be from x equal negative 3 to x equals 0, or the interval negative 3 to 0. And again, it is parentheses, not square brackets. It can't be a square bracket because at those numbers, negative 3 and 0, that's where we're changing. And so you can't say it's still increasing or still decreasing there because that's where it's changing. And lastly, constant in green. So right there, from x equals 3 to the right forever. And that would be 3 to infinity. Again, parentheses. So there's increasing, decreasing, constant. Not terribly hard, and that's all we need for our purposes in this class. Okay, another thing that we're just going to get by just looking at graphs, but if you make it to calculus, it's going to be much more involved. Relative maximums, relative minimums. Also known as local maxes and local mins. So if you're one of these people that look up YouTube videos on your own and you see the phrase local maximum, local minimum, same thing as relative. A relative maximum of a function is the y-coordinate of a high point. A function may have no relative maximum, or it may have many relative maximums. The number at which a function has a relative maximum, or where the relative maximum occurs, is the x-coordinate of the high point. So one of the hardest things about this little concept right here will just be the language. In general, relative maximum corresponds to high point. That part's easy. But then we can get specific about the language. The relative maximum value itself is the y-coordinate of the high point. The location of the relative maximum is the x-coordinate. The flip side, a relative minimum of a function is the y-coordinate of a low point of a function. A function may have no relative minimums or may have many relative minimums. The number at which a function has a relative minimum, or where the relative minimum occurs, is the x-coordinate of a low point. Again, the relative minimums are going to correspond to the low points. But then the language of it. The relative minimum value itself is the y-coordinate of that low point. The location of that relative minimum is the x-coordinate. So you just have to be careful with the language. So the graph of a function f of x is given. Use the graph to find each of the following. A, the numbers at which f has a relative maximum. What are these relative maximums? And B, same thing but minimums. So A. Okay, so here are my relative maximum. Relative max in blue. So we look like we have the point -3, 3. And it looks like, trying to be careful here, it looks like it's 4, 6. Okay, so the first part, the numbers at which those are the x-coordinates. X equal -3 and 4. The numbers at which, the locations, those are your x-coordinates. Then the second part, what are these relative minimum? What are the relative, or it's maximum, excuse me. Those are my y-coordinates, so y equal 3 and 6. Letter B in red, the relative minimum. So it looks like that point there, which looks like it's -1, 0, and this point here, which looks like it's 8, -2. So numbers at which, my locations where things are located, my x-coordinates. So x equal, and that I got that first point backwards, don't I? Yes, I do. Let's fix that. That is 0, -1. So the numbers at which, my x-coordinates, 0, 8. What are these relative minimum? That would be y equals -1, -2. So not hard. You just got to remember the language going on here. And be careful with the language. Okay, continuing on with that concept, relative maximum, relative minimum. The graph of an equation and of a function, the graph and equation of a function f are given. A, use the graph to find the values at which f has a relative maximum and use the equation to calculate the relative maximum value. B, same thing, relative minimum. So A, maximum. in blue. So that's that point there, 0, 0. And so we'd be pretty safe to say that you use the graph to find any values at which f has a relative maximum, at x equals 0, and a relative minimum value, maximum, of y equals 0. Sorry. Oops. So there's my maximum, and it was very clear that it went through the origin, so I'd be pretty safe that it has a relative maximum at the location of x equals 0 and a relative minimum value of y equals 0. X's are your locations, y's are your values. But now in red, my relative minimum in red, right there, and it looks like 3, and even if I were to zoom in on that for you, it would not be clear what the y coordinate is. Now if I were to zoom in for you, it looks like it's somewhere in the 20s. But we can say with a whole lot of confidence that it has a relative minimum at x equal 3 and a relative minimum value of y equal, and now we got a problem because from the graph it wasn't clear. But we haven't used all the information they gave us. They also gave us the function. And we remember that x coordinates go in, y coordinates come out. So all I have to do is take my function and plug in 3. And so I get 2 times 27 minus 9 times 9. And so that's 54 minus 81. And I'm not going to do that in my head. I should be able to do it in my head, but I'm not going to. Which comes up to negative 27, and that looks reasonable for the graph. And so here, the graph on this one, since it wasn't clear cut, we had to go to the formula, which is fine, and it was easy as long as we remember that x coordinates come in, y coordinates come out. And that's where we will end this video.